Problem 24. We're almost home free. So this last problem is asking us to find some areas. So let's go ahead and start with this first thing. I've already drawn it in the interest of time. So what do we want to do here? The idea is we want to cut it up into little parts and find the area of each part. So if I found the area of this rectangle, that's going to be the pink. We're going to start with that. So A, and then I'm going to say rect for rectangle equals 100 times 50 or 5,000. And on either side we have the exact same circle, but I'll go ahead and do it in 2 steps. If you wanted to go ahead and do it in 1, that would be absolutely fine. But A, and I'm going to say right because it's on the right side, it's half a circle. So it's 1/2 pi r squared. What is the radius? So the diameter is 50. So let's write d equals 50. So r is equal to 25. So this is 1/2 pi 25 squared, or 625 pi divided by 2. And now let's do purple for this one, but it's going to be exactly the same. Like I said, if you wanted to do this all as one circle, I would have no problem with that. But if you want to break it up and be safe, that's fine too. Equals 1/2 pi r squared. But again, r is 25 for the same reason it was over there. So we're going to plug in the exact same numbers, which means we should get the exact same result. So then the final area, A, equals 5,000, plus add these two things together, 625 pi over 2. So as a note, I'm adding half of something and another half of that same thing together. So those add together and lose the 2, like 1/2 plus 1/2 is equal to 1. So I get 5,000 plus 625 pi. And if I asked you to give me an exact answer, this is what I would want you to go with. Or if you want to round to the nearest decimal place, you would plug in 3.14 for pi. Excuse me, I have the hiccups. 625 times 3.14. And you would get, this number is, excuse me, 62.5. And then I want to make sure that I'm keeping track of my units. So I'm going to have meters squared. And that's what we have for that. Probably best to put parentheses around this. Okay. Now we can move on to the next problem, which also was conveniently drawn. So for geoboard problems, we kind of have to apply what we know. We have a few different tactics. We could try to add a whole bunch of triangles together. That'll get you the right answer, but it seems kind of annoying. And if you wanted to break it up into rectangles, like using the diagonal from this corner to this corner, you could mess yourself up a little bit because it's not 1, 2, 3. These are actually gotten by Pythagorean Theorem. So I think the easiest way to do this one, personally, is to use the takeaway method, where I find the area of the entire box And then I subtract off all these little areas in here. If you want to use the cut-up method, completely fine. I think it's just going to be a tiny bit more tedious. Okay, so let's start. I'm going to try to do this as painlessly as possible. So all these four corners are going to have the same area. So what is the area of one corner? Area of a corner. That's going to be, it's the area of a triangle. So it's 1/2 times the base. The base here is 1 times the height. The height is also 1, so I get 1/2. 4 of them, so 4 times 1/2 equals 2. Now I'm going to do the same thing with these. Let me choose a color, yellow. With these ones, again, there's 4 of them, so I can find the area of 1 and then multiply by 4 at the end. A of, I don't know, middle equals 1/2 times, now there's 2 units, times 2, times 1, because the height is 1 unit, giving us 1, and then 4 of them, so 4 units squared, here it was 2 units squared. And then finally, area of whole square equals 1, 2, 3, 4 by 1, 2, 3, 4. 4 times 4 equals 16 square units. So 16 units squared minus the 2 units squared from over here. Those contribute the corners. Minus 4 units squared, which make up these parts, like the middle parts junk cutting in, gives 10 units squared as our final answer. Again, I kind of like this technique. It's kind of cool because you don't actually mess with the figure itself. You just find the area of everything in between. But you would get the same answer if you cut it up. But I just think it's kind of cool. And then finally, we left the boring old parallelogram for last. This one, you can't do the cut up method. I didn't really give you the tools to do that. Does that say 6? No, okay. This was 6.4 feet. Maybe I did. 0.4 feet. Yeah, okay. If you really wanted to, you could, because you could use Pythagorean Theorem to find the length of this side here. I'll show that on my drawing. Because this over here would be 5 and this would be 6.4, you could find the length of that triangle and use the cut up method. But that sounds really tedious when you can just say area is equal to base times height. What's the base? 16.2. What's the height? 5. A equals 16.2 times 5 equals 81. And then add in your units, feet squared. So a nice serene problem to end the review.